So, as Alar mentioned, my background is mechanical engineering, so the business model area was kind of a little bit new to me until the last few years. So what I'm going to attempt to do today is meet you somewhere in the middle between mechanical engineering and product development, and where you're from, kind of marketing and business background. Just to give you a little bit of information about who I am, what I do. Well, I'm originally British, but I've been working as a professor at the at DTU, the Technical University of Denmark, for the last few years. If you want to know a bit more about me, you can go to my homepage, see my research areas and my teaching. And one of the courses which I teach on is innovation and product development. And this is very closely related to this course. It's essentially some of the things you're doing, except as well as developing the business models, probably not to the extent you're developing them, we also try to develop the product and make prototypes of the product around it. So from this last year, you can see, am I connected to the Wi-Fi? Yes. So our course is basically run in conjunction with the Venture Cup, which is the biggest entrepreneurship and startup competition in Denmark. So the outputs of the course are all fed into the Venture Cup. All my lectures appear online, so you can just go to lectures, you can click design and business strategies, and here you'll see, and here you'll see the YouTube videos of the lectures and the slides available to download. And these are all on Creative Commons license, so you're free to go look at them and get any inspiration if you think anything you've heard today was of particular interest to you. And just to get an idea of what the course outputs are, you can go to the previous project outputs, 2012, and just go down and have a look at some of the projects produced. So here's a device which they developed, which you connect to smartphones, which can read wind speed, and then it uploads it to a social wind speed network so that you can share wind speeds around the coast when you're engaging in water sports. Here's another project here, Protector, and this project was about security systems, or at least surveillance of people around things like cruise liners, hotels, etc. So if there's some kind of emergency, we can find out where in these buildings or areas people still exist, so the fire service can get straight, or the emergency services can get straight to them. EasyVip, this is a device where you can take away water retention on people's legs. So the elderly at the moment, nurses come to their homes and they manipulate their foot until the water swelling goes down. Well, this was a simple device to help do it automatically. So you can see from my course there's a very broad range of types of products we produce. So of course, because it's a broad range, it means a lot of our methods have to be quite generic and applicable to all. So hopefully the methods I show you today and some of the insights I give you will also be beneficial to your areas in ICT. And of course, if you're interested in what I'm doing and you want to do your master's projects, you're welcome to approach me with an idea and come over to DTU for a semester. Okay, back to the presentation. So as I said, I'm going to be talking about design and product development today. And how it perhaps relates to business models. And sorry, when I'm engaging with you, you might have to cut down on some of the business jargon, as I probably won't understand it. And likewise, if I'm talking in too much design-specific jargon, let me know, and I'll simplify or try put it in different terms. And also, if you can't understand what I'm saying, apologies for being British, basically. Oh. Does this work? Okay, so the agenda for today is we're going to talk about integrated product development to begin with. We're going to then do a short exercise in integrated product development, and I hope you'll engage with me. Then we'll take a 10-minute break. Then we'll talk about product service systems, another quick exercise, another 10-minute break, and then on to open design or open source design through to lunch. So there'll be 2 small breaks. So the first section is integrated product development, and this is kind of the brainchild of a professor in our section called Mogens Andreasen. And to get you started on this, I'm going to give you some quick warm-up exercises to demonstrate the difference between sequential and integrated product development. So in your groups, if you've got a piece of paper and a pen, if you could assemble around now. Oh, I should say this is the recommended reading, Integrated Product Development by Mogens Andreasen and Lars Hein. The first example for your exercise is I want you to use these 6 numbers here and these functions, plus, minus, times, divide, and brackets. And using as few of these numbers as possible, so if you just write them down and discuss in your groups, try and make the number 25. So using as few of those numbers as possible. I realise you're business students, you might need a little bit longer than the engineers. I'll give you 30 seconds or so to do this. Okay, anyone solved it in 2 numbers? Yeah? Okay, go ahead.
5 by 5 equals 25.
You can only use the numbers once, sorry. Yeah, you can only use the numbers once, so it can't be done in 2 numbers. Can anyone do it in 3 numbers? Go ahead.
6 minus 1 multiplied by 5.
Exactly, yeah. So you get the idea. Another option is 7 minus 2 times by 5 is 25. Okay, so this time we're going to do it for real. Now what I want you to do is write down these 7 numbers on a piece of paper, so make sure you do that, otherwise this isn't going to work. And you can discuss in your groups. So remember, using as few numbers as possible, and you can only use this one number once, I'd like you to get as close as you can to the number 24, using as few of those numbers as possible. Okay. So once you've done that, write it down, and then I'd like you to cross out the numbers that you've just used from your list of numbers. Is everyone following? Just let me know if you're not sure what you're doing. So with the numbers you have left, after using the numbers to create 24, I'd like you, with the numbers you have left, to get the number 12. Okay, by now you should be guessing what comes next. Cross out the numbers that you used to make 12. So you should only have a few numbers left now. And now with those numbers left, I'd like you to make the number 4, or get as close as you can to it. Again, using as few numbers as possible. Okay, so how many of you managed to achieve all 3 goals? Okay, so a few of you did it incorrectly then. And of course, most of you, if you've achieved each goal correctly, you probably shouldn't have achieved all 3. But maybe you found a route around it, which I didn't. And the point of this exercise is partly to warm you up, but partly to demonstrate the problems with sequential product development. So as an analogy, we can say the marketing department or the business strategists may have a particular target specification, let's call this 24, because that's the optimum for the market. And they pass over that specification over the wall to the designers or the stylists, and they say, we want you to make a product to this particular specification. Now the designers and stylists have a particular style in mind, and they want to hit the specification of, let's say, 12. And they pass it over to the manufacturers or the engineers and say, can you make this for us? And the manufacturers say, well, not really, we can't actually achieve that because there's too many compromises caused earlier on. So this is an example to show the problems with doing things in a sequential fashion. Every decision you make causes downstream effects. So if you turn your piece of paper over, write down these numbers again, just quickly. But this time, I'd like you to try and hit all three targets at the same time. So you don't have to do it in sequence, just use those numbers to hit these three targets. Okay, so did any team manage to hit all three targets by doing it this way? How many teams managed to do it with 3 numbers left over? Any teams managed to do it with 2 numbers left over? There's a couple of teams there. So what you'll see quite clearly is it's a hell of a lot easier to do things in an integrated fashion. Okay, if you haven't finished quite now, perhaps don't choose so many of the economics modules. Okay, put that to bed now. So the idea is it demonstrates that there is a more optimal way to do it by treating things in an integrated fashion. And this is exactly the role of the product developer. We're looking at the interests or the requirements of all the stakeholders in the process. So we're looking at what the manufacturers want. We want to look at what the product developers and the stylists want, the customers and the marketing department, and we have to put all of these together and try to find the optimal solution. That's the role of the product developer. But this simple little analogy I showed you at the beginning, does it really relate to product development? Well, we can certainly say, and we've shown it through numerous publications and case studies, that the constraints you impose early stages of the development process do have downstream effects on all other stakeholders. So every design decision you make causes problems for other people down the line. Furthermore, product development is greatly complex. There are so many stakeholders involved. So the silly little example I gave at the moment showed 3 stakeholders with a very simplistic model, just using numeric algebra. But in real life, product development is greatly more complex. So it's quite often said that nobody in the world, no single person knows how any product is developed. Even a simple product like a pencil, nobody actually knows how a pencil is actually made. In terms of the person doesn't know how to extract the raw materials, how to process and refine them, how to manufacture and assemble them, how to pack them, sharpen them, distribute them, sell them. No single person knows how to do this. So product development is a task which involves multiple stakeholders. This is one of the most important principal diagrams in engineering design. It's called the theory of dispositions. And this suggests that at the early stages of the product, we're not using a great deal of cost. Of course, we just sat around drawing boards, philosophizing, coming up with ideas. At the later stages, we start committing costs. We start putting money towards prototyping, towards manufacturing facilities, towards labor costs, and so on. And the costs skyrocket. And then it becomes very difficult at the later stages to make changes. You can't just all of a sudden make a conceptual change to your design and change the whole manufacturing plant. By this time, you've already committed too much cost. But alternatively, or conversely I should say, the design decisions you make at the early stages allocates more of the costs than the design decisions you make later on. So the very early conceptual stages commit lots of cost. So when you're creating your business models, you really must think about the consequences of the design decisions you're making, because they have the most impact on the rest of the process. Does everyone follow that? You're welcome to jump in with questions at any point, by the way. Okay, so another quick exercise for you now. Let's just take any product, and for simplicity's sake, let's take the iPhone. But just in your groups, I'll give you the next 3 minutes or so just to discuss and try list some important stakeholders you have to bear in mind when designing a product like an iPhone. And I'll get you started with a few. We have to consider, when setting the specifications, the engineering department and the design department. We have to consider the users and the operators, of course. We have to consider how this product is going to be shipped from the manufacturing site to the point of retail. So these are 3 stakeholders, and just in your groups now, I want you to discuss and try list a few more important stakeholders you have to consider when you're designing a product. So off you go, you've got 3 minutes. Okay. So who can suggest for me another important stakeholder we need to consider when we're designing a product? Go ahead.
Music industry.
The music industry in this case, okay. So the artists and the record labels. Anybody else?
Developers.
The app developers.
Yeah.
Yeah, exactly. The app developers, they're interfacing with your product.
The marketing department.
The marketing department, of course.
Maybe the mobile service not operators, but providers.
Yeah, exactly. The network providers for the mobile service.
Component suppliers.
The component suppliers, of course. Any others that haven't been mentioned? Go ahead.
Yeah.
Pardon?
Somebody who hold the auctioneer.
One more time, sorry.
Some people hold some part of the company, auctioneer.
The investors, of course, yeah, the shareholders or the investors, they're going to be interested in which direction you're taking the product as well. And do we have one last one?
Legal department.
Exactly, that's the one I was waiting for. Legal department and regulations are always quite vital as well. So we really need to consider these types of things when we're designing. Just as an example, Apple, when it came to designing shipping, another one is packaging as well. How are we going to pack the device? I just listed another few common ones here: sales and retailing, how you're going to sell it at the point of purchase, quality control, how do we ensure that these products are robust and always meet the same quality, who's going to assemble them and how are they assembled, how are they disposed of, what is their end of life, manufacturing, how are you manufacturing the components or getting the suppliers to supply, and suppliers. So a nice example of this was the development of the MacBook Air, and they were trying to develop the packaging for it, so the packaging reflected that the MacBook Air was super thin. They wanted very streamlined, thin packaging. But of course, in Britain, we still have these ridiculous 3-pin plugs, which are huge. So the whole packaging of the whole device was based around the size of the British 3-pin plug when it came to Britain. So they then needed to go back to the drawing board and think, how can we redesign the plug so that it's collapsible, so that it can fit with our packaging, so that it can fit with our product, so it looks good at the point of retail. So this is the way the product developer's mind is thinking, is looking at all of these stakeholders and the entire life of the product and trying to optimize it through each of these stages for each of the stakeholders. Now, this is the model which I'm going to introduce to you, which you should see on the screens in front of you. This is the integrated product development model. And basically, to create a business, you start off with some kind of need situation. And I'm presuming more often than not, you're told that this is from a customer pain or a user pain, or identifying a customer need in a market. Whereas it isn't always from that. There are 3 different disciplines. You'll be looking commonly at the marketing, trying to find a niche market or a market space for the product. But of course, the need can arise just from having a cool and interesting product. When I was talking about this with Ala at dinner the other night, he said, where is the customer pain behind Angry Birds? Of course, that didn't exist. People weren't designing to a market need with Angry Birds. They just came up with a cool product, a cool game, which then found a market for itself. And of course, the area that I look in mechanical engineering quite commonly is production capabilities. Lots of new design and new development projects in companies will be started because of the production facilities they already have. So in other words, what other metals packaging can we use to make use of our facilities that we currently have? In Mullins, where they produce tea bags, they now have such fantastic capabilities of producing tea that they have excess capacity, which they're trying to constantly run design projects to find out what else can we do with these tea bag pouches. So they take their production facilities, their technologies, and try to push it out to different markets. So the need situation can arise from either of these three, not just trying to find a new customer need. And all of these stakeholders that we mentioned a moment ago can be mapped onto this integrated product development process. So at the market level, we have marketing, sales, forecasting, user studies. At the product level, we have design, aesthetics, styling, engineering, ergonomics. And in the production end, we have manufacturing, assembly, packaging, transport, and so on. So to give a definition, we'd say integrated product development is an idealized model of development where the business case of the product is built from the perspectives of all stakeholders. In other words, you may have a very great market space for your particular product, but if you don't consider any of the other stakeholders in this process, this product isn't going to work. So none of these particular stakeholders is any more important than another. They all need to have benefit provided for them in this process. So let's consider, this is one product I was working on during my PhD. I was working for a packaging firm where we had to design simple inserts for bottles. So you can see here, this plastic insert fits into the neck of the bottle, and then the metal cap goes around the top of it. And this product was for salad dressings or condiments which you pour over salad. Now there were two products on the market. There was this quite simple one here, and then there was this slightly more elaborate one here, which is made up of multiple parts. You can see the spring inside, and this nozzle retracts back into this, and then this cap goes over the top with this cap screwing on. So to the customer at the beginning, they look quite similar, but their function is slightly different. So I'd just like you to spend a few minutes now, again in your groups, trying to make a distinction between these two products in terms of market, product, and production. So how do these two products differ in comparison when you look at the market? How do they differ when you look at the actual function of the product? And how do they differ in terms of production? Okay, I think we'll call it back in. So who can suggest to me, let's take the market position of these two products to begin with. Who can give me an explanation of how they differ in terms of the market they adhere to?
First one in the left could be like for bars, cafes, for that kind of companies, and second one could be more like for oil companies and food companies producing this kind of beverages, because you can use this multiple times and you can use this only on one bottle.
Okay. And why do you think you can use this multiple times and this only on one bottle?
Seems so.
It seems so, okay. Okay. These are actually both disposable, single serving, the idea is. So they go into the salad dressing bottle, they're used and then thrown away, and they come with every single salad dressing bottle. But I suppose in theory you could pull it out and stick it into a different bottle. Anybody else got a differentiation between these two products at the market level? What type of brand image are they conjuring up? Is one more valuable to a company than another?
Actually, we had an idea that this second one is like design is more is better.
Okay.
Sort of that we would choose the second one.
Okay.
For design.
Okay. That's an interesting point. Well, let's just take that point there. Have a quick raise of hands. Who thinks the first product is a better design product? Okay, we have 1, 2, 3. And who thinks the second product is a better design product? Okay. So the other, maybe half of the room are undecided, I guess. Let's just go back to analysing it now. In terms of the market, how do they differ? Go ahead.
The second one is, I guess, easier to make, so the time to market is earlier.
Quite. This one is definitely easier to make. So at the production level, we've got an improvement in manufacturing and assembly, of course. But just to give you a hint at the market level, I would say they're different in terms of how high-end they are. I mean, clearly this one is a more premium product, I would say. As soon as you take the cap off, the spout comes out. It looks more interactive. I think it's aimed at slightly more premium products. This one is more functional mid-range, so you're looking at brand differentiation with this particular one. Does anyone disagree? Okay, in terms of how well the product functions now, so at the product level, can anyone offer a breakdown of how they differ? Go ahead.
On the more high-end one, there's no cap needed. As a user, I can say that since this opening is rather small,
Yeah.
you can just take the cap off, throw it in the bin, and leave the bottles on your countertop, and it's very easy to use. The other one needs a cap put on constantly.
Okay, that's an interesting breakdown. That's something we didn't actually think about when we were going through it ourselves. But yeah, very good point. So you would say that this product is better functioning product than the other one. Any other comments regarding to how well the products function? Okay, well, go ahead.
Maybe solo one is more reliable.
It's more what, sorry?
Reliable?
Reliable.
Yeah.
I think that's certainly true. It has less moving components. This could be likely to jam, so this one is certainly more reliable. So, as you mentioned, this one is relatively complex, so can malfunction. It's cleaner in operation because the spout is taken out further and the non-drip lip is a little bit better, and it's easier to direct the product. Whereas this one is simple, easy to use, less clean in operation because the product is more likely to start dripping down the bottle. And then finally, in terms of production, can we make a distinction between these two products?
There is multiple components in the left one, and
Yeah.
there is only one component in the
Exactly.
right one.
So which would you say is better for production?
For production, it's faster and easier, I guess, the right one.
Exactly. So this one has only one material, this has multiple materials. This is a one-piece injection molded part, so the manufacturing is very easy, and there is no assembly time. So in terms of production, this is a lot better. So now when we go back and ask the question again, which of these products is better? It's very hard to say. You can't just say one product is better than the other. You have to think about it in terms of integrated product development. And it depends which market you're going for. It depends what production facilities you have already. So maybe you can sell this one for a little bit more, but maybe it costs a great deal more. There are extreme cases of this, of course. The Philip Stark orange juicer versus a normal plastic orange juicer. Now, I would say without doubt, this product here is cheaper, quicker and easier to produce. A downside, cheaper and quicker to produce. In my opinion, it's a much better functioning product. For a start, you get full product capture in the cup. You've got some kind of filtering mechanism here which captures the pips and the zest. It's much more lightweight and durable. It's not going to crack your tiles of your kitchen floor if you drop it. It's a lot more sturdy than this is. If you look at the aspect ratio of this, it's very easy to knock over. Generally speaking, it's a much better product. However, when you look at the market, it doesn't have the wow factor. There are too many products like this on the market. So although you can break the products down into market product production, you also have to know where the value resides. There is little value in the production of this particular product. There is little value on the functionality almost. But they realized, or Alessi realized, there was large value in the design factor, having this as an ornament to your kitchen as well as an orange juicer. Now, traditionally what we do in mechanical engineering is the bottom two phases of product development called concurrent engineering. So we try to make the product function just as well or better, but make production a lot cheaper and easier. So how we do that is we use DFX methods. Has anybody heard of a DFX method? Okay, so here an X represents a stage of the product life cycle. So all of those disciplines you listed earlier, X could mean a factor relating to them. And DF means design for the purpose of improving. So some important DFXs that we have to constantly do is design for environment. So we have to make sure this product functions but is also environmentally friendly or conscious. DFM, design for manufacturability, making sure, again, the product functions well but can be made. Design for assembly, it's quick and easy and simple to assemble. Serviceability, we can service the product. Changeover, it means if we want to run different product variants, it's quick and easy to change the production lines. Disassembly, so once you've made the product, we want to be able to disassemble it for recycling purposes. And for quality, to make sure the design is robust so we can assure the quality of the product at the end. And if we have our product life cycle on the left of planning, fabrication, assembly, testing, transport, installation, and so on, and some of these universal virtues of a product, we can see how some of these DFXs map on. So some run along the stage of the product development process, and some relate to the universal virtues. Now, I'm not going to go into that too much because that is the role of the engineer or the product developer, but it's extremely important that you guys know when you're setting your design or your business briefs that this is the activities that the engineers and the product developers have to go through. It's important you understand and appreciate that. So just to take in a particular example, this is a design for serviceability example of a car headlamp. So you may think, oh, well, all we have to do is make the car look nice, make sure the bumper has adequate protection or safety, and make sure all of these components are constrained so that they don't fall to bits. But if you look at the way this bumper is constructed and this headlamp, you basically put the bulb in, you put on the lens, you put on the lens cover, you then secure this into position by fixing the bumper on top with a number of different screws, and then place the number plate and paint and so on, and you're away. But when you need to replace the headlamp bulb when it goes, what do you have to do? Well, you have to take the whole bumper off. It's ridiculous, because the designers haven't thought in advance about these later life cycle stages. So these are the operations you need to go through. You have to disassemble and reassemble 32 items in order to replace a headlamp bulb. So this is the effect of bad design. Now you can design the thing slightly differently. It looks the same, it functions just the same, but when it comes to service, it costs the user a hell of a lot less to get a bulb changed on their car. So it's just thinking about the life cycle phases of the product. Here's a design for manufacture and assembly example. The Boeing helicopter, formerly the formerly McDonnell Douglas. They made an estimated saving of 1.3 billion over the life of their program by applying DFX methods. So one example is this anti-flare bracket. And in terms of functionality, these products function almost exactly the same, but it was originally made from very standardized parts, very simple, cheap parts, which you either weld or you tack together with rivets. And it comprised of 5 sheet metal parts, 19 rivets, 20 tools needed, and 32 hours of manufacture. By running some simple DFX exercises, we have a product which functions just as well, in fact a little bit better, but instead we have one high-speed manufactured part Just 2 hours of manufacturing, 10% less weight, 45% less cost, tooling virtually eliminated, and no assembly. Just from thinking about the life cycle phases. Again, here's one of the jump seats or ejector seats. You look at the number of parts they've used to make this work and function correctly. Very simple DFX, designed for assembly approaches, helped us reduce the number of parts in this product drastically and significantly. So these are the effects of thinking downstream, thinking about the later life cycle phases. And here's just one very simple example again of a corner bracket. Here you use simplistic, simple Meccano parts almost, which you weld or tack together, and each corner bracket will comprise of 4 different parts. And instead they just go for a slightly more expensive corner piece and eliminate assembly. And it's up to them to think about the trade-off, what's more valuable for their process. Here's a nice way of producing design for assembly examples through using plastic parts. Here you can see a peg, 2 different materials, 2 different components, because the wooden ones are the same components. Assembly is a little bit tricky. Obviously when it goes to decomposition as well, you have to separate the parts. Here we've got a one-piece molding, which is basically molded flat, and then you hinge both sides of the peg back over and use this integral hinge in the middle to basically replace the metal spring. So here the designers have tried to come up with the same functionality by using a single material. And this plastic bell, instead of using multiple components, multiple parts, very expensive, this whole piece here is one plastic molded component. So they've got the ratchets here into the molding. This little peg here is used to strap it onto the handlebars. The plastic molding comes round, and then this part of the plastic molding is used to activate the bell. So they've managed to reduce this to just 2 parts, basically. So the part of integrated product development, which I guess you guys will be most involved in, is the distinction between the product level and the market level, the upper 2 strands of integrated product development. This was the result of a project which I did with a student from Tallinn University who came over to visit. It's one of our publications. And this represents the activity life cycle of a particular product. I'm sure you've got lots of different ways of representing this, and you probably know more about it than I do. But basically we broke it down into the company's activities in providing their product or service and the customer's activities. And this particular example here was for furniture supply. So the activities from the customer in traditional furniture supply and the company. And we just took as a case the IKEA example, where 2 of the components from the customer's activity cycle are simply transferred over to the customer's activity cycle. And that demonstrated an innovation in their business model. So obviously these 2 components were the transportation of the product and the assembly of the product. So an important thing to do when thinking about IPD is think about the activities and the life cycle. And I think this is my favorite model or description which I think you can all use. This looks at mapping the life cycle of the product, from where it comes from its raw materials, to how it's produced, to where it's going to be assembled, to how it's going to be transported to its sales point, to how it's going to be sold, to how it's going to be installed, used, maintained, and disposed. You can have exactly the same product, but an innovation in any of these points, and your product could be the market-leading product. It doesn't necessarily have to just have a bigger market share or function slightly better. You can make benefits in all of these areas of the life cycle. The other life cycle you need to consider is the user's activity cycle. So once the user gets it, well, before the user gets the product, the user is doing some activity. They get the product, they then put it in storage. after storage, something tells the customer they need to use their product. So then they go and get the product. They then open the packaging. They then start using it. All of these are activities. And at any point of this activity cycle, you can make your innovation. So you can differentiate your product from any other product at any stage of this activity cycle, as well as any stage of the product life cycle. So what I'd like you to do now is think about sun cream. Now, my skin is terrible. I cannot stand out in the sun for 2 minutes without getting burnt, even in Great Britain, even in Estonia, even in Denmark. It's terrible. I'd like you to think about the problems with sun cream and just think about where it comes from in terms of the product's life cycle and how the customer uses sun cream. So in your groups, just have a little discussion now and make some notes about the stages of the product's life cycle of sun cream and the activity cycle of using sun cream. Okay, so before we go to the break or the plenum, now I'd like you to think about how you can change one of these stages of either the product life cycle or the customer's activity cycle to reconfigure the product of sun protection. So maybe you can change this life cycle or the customer's activity cycle to deliver a product in a new way. So just choose one or two elements and see how you can deliver it differently. I'd like to just talk through with you what are the different stages of sun cream production. So production. How is sun cream produced at the moment, or sun care systems produced? Well, basically it's produced a sun protection factor formula put together with some moisturizing cream, put into some plastic packaging, then it goes on to the next stage. So assembly for this particular product, how is assembly done? Go on.
I'm just thinking that this.
Ah, you did it right. How is it assembled?
It's simple. It's like the plastic thing moves, you fill it up, locks, you close it.
Exactly. That's what happens. Of course, there are some assembly parts around the packaging as well, but pretty much that's it. Bottle comes in, it's filled, it's closed. Then transportation. What happens to the product after it's been produced in mass at the factory?
It's packaged in the ship
It what, sorry?
packaged in the ship and shipped to wherever it is supposed to.
And where's it shipped to? Sorry?
Global markets.
Global markets. But where do you buy your sun cream at the moment?
In the shops.
In the shops. In supermarkets. So the point of sale is in supermarkets at the moment. Then installation. This is a generic model, so installation for sun cream isn't really existing. Installation is for things such as televisions, washing machines, etc. And then you have the use phase. Now let's think about how a customer uses or interacts with sun cream. What's the first stage that the user interacts with the need for sun cream?
And it goes out and feels the impact of the sun.
So suggested here, the first point is when the user goes out and feels the impact of the sun. Does anyone else say that is the first stage?
No, it's just when they want to prepare for the sun, they go and look what the sun factor or what the factor of protection is on that.
Okay.
What it does.
Where do they do that?
At supermarkets. Or where the store or everywhere. Where sunscreen is distributed.
Okay. So they have to go to the point where the sunscreen is distributed. If it's in supermarkets, at that time it might be a rainy day. And they might think ahead and see this product on the shelf and think, okay, what sun protection factor might I need in a few days' time or in a few months' time, and buy this particular product. So that's the first point. What's the next activity the user does?
Read the instructions.
Might read the instructions. Not if the person is me, but so you've found it on the shelf, you've seen the sun protection creams on the shelf. What's the next activity?
Choose by protection level, by brand, by price,
Okay.
by ease of use.
Absolutely, you make a selection. Then the next thing is? pay, take it home. The next thing, use it. Well, store it first. And the storing has to be done in apparently cool places away from sunlight, apparently. Then the next thing, what do you do after you've stored it with the sun cream? Use it? Do you use it, or do you think, okay, I might need to use it later, I might need to pack it in my bag, or I'm taking it on holiday, it's not sunny yet, so I need to pack it in advance for using it later on?
Well, depending if the sun is already out.
Depending, but it could be either. So it could be the next thing, repack it, take it somewhere. Then the next bit is apply it, put it on. Then the next thing, perhaps reapply, and then maybe find out whether you've burnt or you haven't later on, and then restore, and then realize that it's too old and throw it away and buy some new stuff. So when you think about all of those phases, you can make improvements at any one of those phases. Your product could be reconfigured by reconfiguring this product life cycle or the customer activity cycle. So one of the first problems with the sun care cycle is we need to think as customers way in advance when we go food shopping or grocery shopping that we might need this sun care product. And then we buy it and we take it home, and we have to make sure we have the right factors for the right sun exposure on the particular day. And then on the morning we have to take it out with us. What if we reconfigured this model so the sun protection is at the point where we need it? So when we go to the beach and it's hot.
So it's like selling for
Exactly. So how do we do this? How could we get sun care to the point where it's needed?
One of the model could be like you sell in the offices this coffee alternatives, and there could be like sun cream alternatives on the beach.
Vending machines, you mean? Okay, so here's an example. At beaches you might have vending machines for Coke or coffee. Maybe you could have a vending machine for sun cream.
But you can't use a vending machine if the plastic bottle looks like that. You
Yeah.
can have those, those like testers that are sell creams in those.
Hey, good idea, good idea.
So it's for a few times use, but then again,
Absolutely. So now you need a slightly different product because you set up the supply chain slightly differently. So maybe we just need small sachets for single use at the point of use. But then there's the problem. I did a little bit of research into sun care, and SPF, the sun protection factor, isn't the most important thing, it's coverage. So another thing you can do is try redesign the packaging so that you get complete coverage. What happens if we manage to design a system around sun care where you can tell when you're completely covered, or you can identify the parts that aren't covered in your body? There are lots of different products or ideas around this type of product where you can reconfigure it. Instead of what's currently done, which is let's produce a new bottle or put an extra star on the bottle or something like that, which is currently the innovations, apart from perhaps spray. So the product we developed was, as you suggested, these small sachets of sun cream, and the idea for us was to try tag it onto current distribution lines. So obviously the problem with getting it to the place where customers need it is I don't want to be driving around the country or employing people to drive around the country supplying to these various points just to put sachets of sun cream. So we need to tag onto current distribution lines. So the idea was we sell this product to ice cream companies who then distribute it with their ice cream to their ice cream vans. And these sit on the top, and in the UK they're £1 per sachet. So when you go to get an ice cream, you just pick up a sachet of sun cream for your kids or whatever, and all the distribution is done and they take a small cut for it. It's also distributed, we're planning to distribute it to national parks because they have common suppliers to their shops at national parks. Go ahead.
Why is it so expensive?
What?
£1, it's a lot of money.
I think that's reasonable. I think it's completely reasonable. I would definitely pay if it was a hot day, I had no sun cream, I would definitely pay £1 to stop myself burning. And well, does anyone disagree? Would anyone not pay £1 to stop themselves burning? Go on.
From an ecological point of view, it seems rather wasteful because it's a lot of packaging for a small amount of stuff inside.
That's very true.
And you're making tons of product there.
That, not really, because we've added somebody extra into the supply chain, because the distributors and the retailers have to make a cut off it as well. Also, you'd be interested to see the statistics of how much sun cream is thrown away. So these big pots of cream are shipped all around the country, shipped back and forward to places they're not needed. That's a lot of volume of cream, whereas why not just ship small amounts to the places where they're needed and get complete product use? So I think you're right. We were concerned about this. I was also very concerned about the fact that you've got places of natural beauty and then you've got these little packets lying around. That would be a hideous thing. So realistically, we'd like a vending machine. And another way you can reconfigure it is the components, how sun cream is produced. You have the SPF factor and the moisturizing cream. Well, can you combine those at the point of distribution? So at that point, you can select your sun protection factor and it mixes it up for you. You pay £1 and you get a squirt of cream. So the message to take home from this isn't about sun cream, obviously. It's about think about your product or the current products in your marketplace for your own projects in terms of the current product's life cycle, the way the product is given, and the activities the customer has in interacting with the product. Do you have any questions?
From technical side, you showed this package. How sun cream is filled in these packages?
Same way that ketchup is filled in ketchup sachets. It's very standard procedure. If you want to know technically, it's called a form, fill and seal. Form, fill and seal. So you just have a long tube and the product is filled through the tube and then is sealed and snipped. But again, don't think about sun cream. Think about the model and how you apply it to your own projects.